So in this video, what I'd like to do is to introduce some basic aspects of the SuperCollider syntax by means of an example. And the idea is that we will develop a simple program in order to show the basic elements that are to be used while writing in the SuperCollider language. So there will be no sound, but there will be some graphic user interface. So we will use graphic user interfaces known as GUI as a way to introduce programming. So we'll create a small program. I will improvise some code, and probably I will make some mistakes, and I will debug these mistakes, because debugging is of course a crucial aspect in programming. So well, it is important to understand how to solve problems, assuming that they will be shown in this video. I don't know, because I will improvise a very simple example. Now, why is it interesting to have graphical user interfaces? Well, first of all, because typically when you think about programming, you typically are focused on writing as opposed to using graphic objects. This is wrong, in the sense that SuperCollider provides you with a lot of graphical user interfaces. The point is that you have to program them, so maybe it can be a little bit more difficult at the beginning, but on the other side, this also means that you can use all the possibilities of programming to create user interfaces. And the other interesting aspect is that object-oriented languages, in some sense, have been originally created having in mind the programming of user interfaces, of graphical user interfaces. So also historically this can be interesting, because surely this is the domain of graphical user interfaces is well fitted domain for OOP. So we will start with making a window. A window is indeed the most basic graphic elements we can think about. So suppose you want to make a window in SuperCollider. Where will you start? Well, of course, if you want to make graphical user interfaces, you can go to the help browser. You look at the help browser, you can maybe search for graphical interfaces. We call them GUI, graphical user interfaces. Let's see what's going on here. You see there are many classes related to GUI, and maybe we can simply start with the most general help file like this, and you see GUI, factory abstraction for all GUI related core classes. So you can also see a list of GUI classes, and maybe better, introduction to GUI, right? So this is the help file you need. But actually we will start, well, of course, we will gain over my little experience. We will start directly by writing. And so, well, window. Is there a class window? Yes, there is. So we want to make a window, and if we want to make an object from a class, we know that we should send a constructor message to this class. Something like this. let's try this. Well, actually, as you can see from the post window, we have a feedback, a post saying a window. So we have one window. So actually we are creating an instance of a window. But as we want to modify and to refer to this window, we assign this window a name like this: W equals window new. What does this mean? Well, it means, as we know, that we are creating a new instance of a window by sending a message new to a class. We get back this instance and we call this instance W properly. We are reserving a memory location, and this memory location is referred to as W. But from a linguistic point of view, we can think that we have an object and we have provided this object a name, a way to address it. So what is W? Well, it's a proxy, it's a container. As you might know, this is known as a variable. So W is a variable. What about variables names? How do we choose them? Right now, we will use all the lower case single letters as directly available names for variables. So we use W, and an important principle in programming, we use W because we want a window. Of course, we could use also C or maybe F, but as we want a window, we use W. It's easier to remember things that are related to a certain semantics. So meaningful names is an important principle in programming. So now I'm cleaning the post window. Now W is a new instance of a window. Fine, but where's the window? Well, actually the point is that to see the window, we have to send a message to our window like this, and now you will have a window. I have to drag it on the other screen because there are two separate computation threads. That's not an issue. As you see, you will get something like this. So you get a window. So as what happens typically is that one thing is to create the window and another thing is to have it show up. This can be useful in some specific situation, but typically what happens is that we have here an application. We will use an application of message chaining. So a typical expression will be something like this: window new front. Here, after here, we have in this space, we can think about these computation steps, and we have the new instance, and on the new instance we call front. Right. So what to do with this window? Well, first of all, an interesting aspect is the following one. We can have our windows and we can close the windows directly in this way, graphically. So if you open parentheses, you will see that there are many arguments of the constructors. This means that we can create a new window with some specific features. We will not see all these features, and by the way, you can see that all these arguments, they have default values, so we are not forced to specify them all, and in fact I have specified none of these features in my first attempt. But let's consider the first two arguments, which are very interesting for us. The first one is name. Now, you see that all the arguments have a specific definition. So name, bounds, resizable, border, they are all keywords, that is, name associated to arguments. We can decide to specify these arguments by say something like this. Name. Let's do this again in this way. So this is the keywords for the arguments. We could say that this is the name of the arguments, and you can see that it is shown in green. Now, what is this? This is the value that we are passing to these arguments. So we want a new window with a certain name, and this name value is test. Let's show what happened here. I have to drag it here on my screen. Now, what is name is the name of the window, and which is the value of these arguments? The value of this argument is test. Now look at the test in our code. You see that there is this double oh Jesus, what's the name of okay, let's call it double ticks. Okay, so we have these double ticks, and this double ticks is a specific marker identifying a specific kind of objects, a string. What is a string? It is a very well-known, very widely used objects in programming. It simply represents a block of characters, like a block of text, text. So actually we want to have a label on our windows, and we use a string. A string is an interesting object. So if we use test and we take into account test, we see that there are some interesting aspects of strings. Well, of course, it is a string, and strings share some features with arrays, because at the end they are sequence of elements. Most of methods of arrays simply do not work with strings, but some do, like this. So you see that we have access to the second element of our string, like this. T is the last element. By the way, just to give you some hints, we can also use this. First is the first element. If we are conceptually, we could write 0, no? But actually this may be easier to remember if we are working with some specific position like first or last. Now, last refers to this one, while first refers to this one. We are sending messages to our string object, and we can do something like to upper, if it is the, let me see if it is, yes. So, and we get back the uppercase version, capital case version of our string. So a string is a manipulable object, a class used to represent strings, sequences of characters. Fine. So this is the first argument. Note that we can skip the keyword. We get exactly the same window, no errors. Why? Well, actually the point is that if we provide an argument, a value, and there is no keywords, the first argument is associated with that value, as the interpreter cannot know what arguments we are thinking about, and so he says, okay, so you're giving me a value, I will associate this value to the first available arguments. Now the second argument, let's go back here for sake of readability. The second argument is bounds. Bounds means limits, no? So the borders of our windows. And in fact, when we evaluated our code, we get a window, but it is apparent that we would like to control the dimension and position of the window. These parameters are controlled by the bounds arguments. So, of course, we have not passed any value to bounds. We were sticking to the default values, but how do we specify position and dimensions? Well, this is interesting because it allows us to introduce a specific class and a way of thinking typical of object-oriented programming. So, we want to specify a position and a dimension. What is the right object to do this kind, to perform this kind of task? Well, of course, a Windows is simply in terms of its shape, it's just a rectangle. Placed a rectangle with certain dimensions, placed in our screen. So the right object is a rectangle. And so we can create rectangles in SuperCollider. We have a class called rect, not rectangle, but rect, and we can create a new instance of rectangles. Like this, rect, new, and if you open new, you have some parameters to create a rectangle, like the left and top position. Left and top are to be specified by using pixels. So if we say 0 and 0, we start from the corner, typically it's the top left corner of the screen, and then we have a width in pixel, and an 8 can be in pixel 2. Now rect is in some sense more general. Pixel is something that we introduce in order to define the semantics of this rectangle in a specific context, like a graphical user interfaces. But the point is that for everything in SuperCollider there is a class representing a sort of, how can we say, metaphysical, if you want, an essence, no? The idea of rectangleness, if you want, from which you can create concrete rectangles. So what happens typically is that here we place rectangles, a specific rectangles. Like this, we can say 50, 50, that's the top left corner, and then we want to have it squared by 100, or maybe let's differentiate them, 100 and like a strip, 20. Let's see what's going on here. Now we have these very, very small windows. It's 100 pixel, and it's 20 pixel, so it's really an horizontal strip. Typically I'm not so focused in this case on these parameters because you can move your windows, no? That's what we are doing right now. So can we learn something more from this? Well, yes, now we have a window and we can ask these windows, which are your bounds? So tell me, windows, which are your bounds? And as you can see now on the post window, it is the dimension is 120 as we have specified. But of course, top and left have changed, so it's 2412 and 359. Why? Because I moved I move the window, and by moving the window, I'm moving, of course, its top left corner. So we could also use this kind of syntax. So rather than asking the bounds of my window, I can set the bound of my windows. So rather than getting, we can be interested in setting, getter and setter. So when you have a certain property, accessible property of your object, you have typically the name of that property can be used as a getter method. So like this, hey W, please tell me your bounds. But you can also say hey W by adding simply an underscore. Hey W, tell me, hey W, this will be your bounds. So the value of that property. And how do we specify again the bounds? By a new rect. So we can say, let's do things easy. We're not interested in top left, but we could like to have something like 100 and let's say 500 this time. So if you see this, you say we are setting the bounds with this new value. And this time you get something like this, which is a sort of vertical strip because it's 500 here for 100 width. So getter, setter methods. You see that we keep on working with the same kind of interface, meaning we just send messages to objects. These messages can be used to investigate properties, like what is your class? But these messages, of course, can be used to change our object. So, hey, W, please change this kind of property. So, of course, you may ask yourself, how do I know which are those properties? Well, there are the help files, of course. Help files are fundamental. You cannot think of working without help files. This is normal in every programming languages. Well, maybe in every software, but maybe with some graphical software you try moving things and putting things together, typically with bad results, in the sense that you start in a very systematic way, making a lot of mistakes. You will do a lot of mistakes in SuperCollider, but one of the interesting things of programming is that you're forced to endorse a more structured approach. So you just go to the window help file, to the GUI help file, and try to understand what is going on. You look through the help files, the examples of code in the help files, and you try to investigate various possibilities of your or of the class you are interested into. So W, hey, this means W, tell me your background. Nil, there is no background. Can we add a background to our window? What is a background? Well, actually, when we speak about background, we are meaning color. Now, so the first point is, how do we represent color in SuperCollider? I guess you are already on the point. We have a class for colors. So if we want a color, we create a new color from a class color. Like this. We could say that C is a color new, no, not BU, but new. And if you look at this, you see that we have 3 parameters. These parameters are RGB, that means red, green, blue. So every color is specified in computers in terms of relation between these 3 color components, red, green, and blue. Sorry, I have to quit various applications, and I will. And So color new, and you have to specify the 3 parameters: red, green, and blue. Range, well, by default SuperCollider tries to set its ranges in the between 0 and 1. So 0 is the minimum and 1 is the maximum. So if you do this like 1 0 0, you may ask yourself, what is alpha? Alpha is the transparency. So 1 means completely opaque. And if we do something like this, we get a new color. What to do with this color? At this moment, nothing. But we can say something like this. And we get a bright red windows as specified by the setter method, to which we have passed C, which is a color. So we have a certain color. We can do something like this, and of course nothing has happened now because we have just changed the value of the variable C. It is not enough because we have to say to the windows, please change your background according to this new value of C. So now we have yellow 1 1 0. Now I'm using 0 and 1, but of course you can have something like this. I'm randomly creating a color, and you have this sort of brownish greenish background. So there are many constructors, by the way, of color, and this is another interesting case, such as array, because color can be interesting. It can be interesting to define this color in a more, how can I say, easy form rather than specifying RGB, because by specifying RGB typically you understand nothing of the resulting color, or you are really into that, or you do not understand which color you will get. But there are other possible models for the specification of colors, and typically one is hue, saturation, and value. Hue, specify the hue from red to yellow, green, cyan, blue, purple, and red, like on a wheel. Saturation is the amount of well, technically of pigmentation, so of color, while value is the amount of lights, meaning the amount of brightness. In fact, sometimes this model is called hue, saturation, brightness. So if you want to have something like red, orange, probably you can do something like this, 0 1, because you're moving from red to yellow, green, and so on. And if you don't want it too much, you want a soft, not so much saturated red orange, you can do something like half of the saturation. And if you want it a bit darker, you can do something like this. So we can say that our C now is made in this way, and we can set the background. Well, in fact, it's a sort of orange if you want. A dark orange becomes a sort of light brown. So another interesting features emerging here is that we are doing interactive programming with object replying to us in an interactive way, and I am using this window, this text window, more than as a sort of page in which I write sequentially. I'm using it as a sort of, well, whiteboard. So just taking notes and changing. So as you can see, this order in this moment is not relevant, because what is relevant right now is the order of execution. So I'm just moving the cursor and writing things and see what is going on. So now we have a window, and well, we can set some interesting parameters for this window. Let's do this. Let's start from the first from the first line and say that well, by the way, the setter method is interesting because it's a typical case in which message chaining is useless. What happens here is that in all cases, all these methods, they just return the object. So we can keep on chaining. We can keep on chaining our object. So we want maybe sort of let's try this. We take this and we do something like this. We are structuring a little bit our program. So note that this is a single expression. So this is a single block that is interpreted by the interpreter. It is a single block, even if it spans more lines. Lines are irrelevant for SuperCollider, like spaces. If you want, you can do something like this, which is highly stupid and useless, but it is legal. So this is a single block because the interpreter will start here and go until what? Well, until it finds this special sign. This sign, I think it's the semicolon. This semicolon is a specific marker saying that to the interpreter that the interpreter has to stop collecting symbols and trying to understand the meaning of what we have written. So every time you put a semicolon, this means that you are separating an expression from another one. Now, for the moment, our program simply contains one expression, this one, and we are evaluating this expression. So now I'm closing my window and starting back, and we have a cool purple stripe like this. Now I'd prefer to go for some squared shape, and I prefer to have something like this. So another thing that it's useful to understand is that sometimes you can skip. Well, it's just an abbreviation, but it is important because you will find it a lot of times into SuperCollider help files. You can skip the new. So if you have something like this, it might happen typically that you find something like this. Now, given, taking for granted what we have seen until now, this second expression should mean nothing to you because you see a class here, but you don't see any message. So what does this mean? Well, actually, this is just an abbreviation. Sorry, I'm trying to select everything. This is just an abbreviation of this. So if there is a class and you see open parentheses, the interpreter means, you're a bit lazy and you do not want to write this. So actually, this is meaningful because it's just an abbreviation of new. I'm telling you this because you will find this a lot of time. And so we will omit this. So the constructor is so common that it's typically. sorry, that is typically omitted. Okay, so it's exactly like before. We have learned something about way of writing, about syntax, about objects, about classes, about way of writing. Now we have a window. What to do with a window? Well, a window is a general container. So every time you open a program, you get a main window. But typically what happens is that in these windows, there are other objects with which it is supposed that you might interact. And if you're thinking about doing something with your program, with your graphical user interface, you might think about slider, knobs, like number boxes. So all these kind of classes and all objects through which you can interact with your software. So maybe you'd like to have a knob that you can move, you can rotate it in order to control certain parameters, like wow, wow, right? Or just think about a slider, you get the volume. So these kind of functionalities are useful. So can we create, let's say, a knob? Of course we can. And we will use a class which is meaningfully known, named knob. So how do you create a knob? Well, of course, by this. And as you know, we could write in this way. I'm not a fan of syntax abbreviation. Syntax abbreviation are called syntax sugar. I'm not such a fan of sugar, in particular for newbies, but the point is that this kind of abbreviation, some abbreviations are so common that it is a good thing to know about them. So let's make a knob. Let's be clear at least now. And if you open a knob, you see that there are a couple of arguments. The first one is parent. So the point is that when you have a knob, the knob is related to a certain window. In fact, when you drag the window, well, of course you will assume that the knob will stay in the same position, not of your screen, but of the window, dragging the window, the container windows, and you assume you will drag also the knob inside the window. So the idea is that the knob must have a reference parent, and the parent is the container window. So what do we pass as an argument? Our W, because our knob must stay inside W. And bounds, well, bounds are exactly like before. It's a rectangle specifying the position of a knob. You might ask yourself, say, but if it's a knob and it's circular, why specify it as a rectangle? Well, it's easier. It's the rectangle in which you place the knob. And by the way, the largest dimension, as a knob is a circle, the largest dimension will be used as a square, where the knob will be located. So let's make something like this. So we place this on top, and we want it exactly right as our window. So our knob will occupy all the window. So it's a nice object, a bit excessive, but you know, minimal, brutalistic. What to do with a knob? Well, you can move it by using the mouse. You move it. Fine. There are many graphical aspects of this object, so you can control this color, this color, this color. I will not go into this because we have no time, but actually it's the same logic. So as you have key, you can change key. Key, give me your color, and so on. Maybe there is something in our knob. You see, let me see, color here. The colors used by the knob to draw the following elements. And by the way, you can see that changing this color gets arguments, is an array of 4 colors specifying the main knob color, the value indicator, the deviation indicator, the background of the deviation indicator. So many graphical parameters. Now let's skip to this. We like our purple and white object and think about the way this knob works. So actually we have to think that surely, yeah, we can move it, but it will be interesting to understand which is the value of this knob. Is there an intrinsic value of a knob? Well, this is an interesting thing that you probably never have thought of until you program it. Because the point is that when you move a volume, you know that you can go from minus infinite to 0, maybe in decibel. Or you can have other kind of ranges. The point is that the range of your object, in that case of the physical object, depends on what is controlled by the object. But in this case, we are controlling at this moment nothing. So which is the range we are using? Well, as we do not know the range, the point in all these, most of these graphical object involving a range of values. So the point is, what is this? What is this? Minimum and maximum. Typically what happens is that in an abstract way, this is 0 and this is 1. But can we investigate a little bit more the value of our knob? Well, sure. By asking knob, which is your value? And if you evaluate this, you see that it's 0.6, a little bit more than the half. And if we move it here, we can ask again, what is your value? And we see that it is 1, so we move it to its minimum here. So tell me your value, and this is 0. So we have a way to access the value of the knob. Interesting. But can we also set the value of the knob? Yes, sure, with a setter notation. And we know that it goes from 0 to 1. So let's say we want exactly the half of our knob. And you see that our knob has been updated to take into account the new value that we have passed. And now it's exactly in the half. Interesting point. So, is it enough in terms of creation of objects? Well, of course, these are some basic aspects, but still we're missing a crucial point. The crucial point is that our knob actually has a value. We can access this value. We can set this value, but the knob does simply nothing. So it's a working useless knob. Well, it's working, so not bad, but it's useless. So can we use this knob to do something more interesting? So the point now is that we want to move the knob and we'd like to have something happening. What can we control? Well, if we consider the point that we reached, we know that we can change some features of our objects. Take into account, let's take into account the window. We know the background can be changed, the color of the background. So, as a working hypothesis, we could try to understand how to change the background of our window by means of the knob. So, we'd like to implement this. Moving the knob will change the color of the window. Now, of course, we have not set up how we want to change this color. This is a specification that we will implement later. But the point is that we'd like to associate this action to the knob. So, if we think about this would mean that every time we inspect, or better, the interpreter inspect a changement of state into the knob, something should happen. So if we just press, nothing would happen. But when the value of the knob change, then something should happen. So the point is that at this moment we are creating a program, and now our program is made up, you see, of two expressions, and the one creating the window and the second one, line 6, creating the knob. And now what happens is that we'd like to create a sort of sub-program in some sense, specifying what should happen when we move the knob. How can we do this? Well, first of all, maybe you'd like to take notes, and maybe you're taking notes, and maybe you're taking notes on paper, or maybe on a text editor. An interesting point in programming is that you can take notes inside the program by adding comments. So, like this, you prepend this double slash here, and you create a comment, so something that will be skipped by your program. So you can take notes here, so you can document your code, which is a very important aspect of programming, because typically what will happen is that you understand something, write down code, then you read it back 2 days later or 1 day later, and you simply do not remember what you did before. So documenting is important, not for other people, but first of all for yourself. So here we add a couple of comments: create a window, and a second comment here, create a knob. Another interesting syntactic element. Maybe when you start with a certain project in a more structured way, you want to add a title, and in this case maybe you want to have a multi-line element. So this code creates a window and a knob changing. Now we want to move to the next line. We can, because this is a multi-line comment. Starting with this, all what follows is a comment until this is reached. So another convention. This code creates a window and the knob, changing the Windows background color while turning just with some line. Okay, so we have a title for our program, and we start by documenting each block. Fine. So back to our problem. How do we change our background? Now the point is the following, is that we want to associate an action to the knob. How can we do this? Well, it's easy. Okay, action is a way in which we setter notation, we set the action related to knob turning. So action is an attribute, and in fact you can expect it in this way. So, hey K, tell me what's your related action? Nil. So there's no action related to our knob. In fact, we can keep on moving and nothing happens. So the point is that we'd like to add something here inside. So our work should focus on this, on adding an action. In order to add an action, the idea is that every time we update, we change the status of the knob, something must be executed. So the idea is that we should have a sort of small sub-program to be executed on command. Is there a way to create such a program? Well, yes, because a typical way of working in so-called structured programming is to encapsulate functionalities into separate blocks. And this idea is implemented in SuperCollider by means of a specific construct, very, very, very important one, which is simply called function. So a function is block of code to be executed on request. How do we create a function? Well, in order to create a function, so now we take a small detour and go back to our example later, we create a function by means of this. So by using curly brackets. Where are curly brackets on your keyboard? You should discover it, because this is very important. There will be surely a shortcut somewhere to create curly brackets. Well, it depends. If you use an American keyboard, you have already available curly brackets. If you use an Italian one, typically you will have to use a couple of keys to get to the curly brackets. So this is a function. This is a function, an empty one. These are only the limiter of a function. What is the point of a function? The point of a function is to have a program embedded, encapsulated inside, that can be used when you want. Why should you bother with functions? Well, typically it will happen in your program that you will have blocks of code that should be used many times. It doesn't make any sense to duplicate these blocks. You simply encapsulate these blocks in a function and call the function back. So the point is that every time you program, if it happens that you are duplicating things, then there is something wrong. Then you should do something more elegant. More elegant is not only a question of style. Well, style is important in life. Typically what happens, you know, there is this famous French indication, so the style is the man at the end, no? But the point is that more elegant means that it is easier to read, it means it is easier to debug, and it is probably also faster to execute. The shorter, the better. Mostly, not always, but typically. So what happens is that it might happen that you have a block of code that is used again and again. You place this block inside a function and you simply call the function. So a function is just like a functionality embedded into one thing. Now remember that this is an object. Okay, so here we are creating an object. And we are assigning, is just like making a function new. I don't know if this is legal because nobody writes in this way. Well, no, of course, there's a mistake. Doesn't work in this way. But actually, in a sort of pseudocode, you can think about this like function new. It's just like when you write an array directly in this way. So here we're creating an object f, which is a function. And so f, what's your class? Function. Right, so we have an object. So this object can be used in this way. Once you have created a function, the content of the function will be executed when you ask for the code. When you ask for the function, hey function, please, it's like value, that is, evaluate yourself. Point is that our function is empty. But let's suppose you have a function like this. Now, we can also write it in a more tight way, like this. Now, this function contains string postline. So contains one expression here saying to the string, hey man, printed on the screen. So we are sending this string, this message. Now let's evaluate, let's create the function f. As you can see on the post window, nothing, well, it returns a function, but of course there is no sign of evaluating its inside, because this expression is not evaluated. It's just like you're creating a, let me say, something like a juicer. So to create a juicer is not to have it working. To have a slicer, go to the shop and you buy the slicer, the slicer is not working. You have to turn it on and off. In case of function, it's the same. You create your slicer, and when you want, you turn it on, and it works. So now we have f, and how do we switch on this slicer of ours? By this way. Function, evaluate yourself. Function, switch on. And in fact, in this case, what happened is that on the screen we see on the post window that this expression has been evaluated and executed. Last thing, we see that this expression is returning, this function is returning something, as any other message we send to a certain object. Every time we send a message, something it is returned. What does a function return? Well, interestingly enough, what happens is that the function returns the value of this last expression. In our case, there is just one expression. Our expression simply asks to print on the screen this string. So this string is actually returned by the function, because value say to the function run, and by running the function performs the computation inside and returns the last expression, in our case the only expression. So what we have back from this block of code is a string, and we know that we can ask what is the first character of a string, so we are expecting here an h. In fact, as you can see here, you have h. This means f value, what is returned here is this string, and we are asking for the first element. So it's only chaining. You just follow the computation, always the same kind of mechanism. Now, this idea of a function is interesting, because we can encapsulate small programs inside functions. Now, this was a really stupid one, if you want. Well, not so much, because sometimes it might happen, many times during your program, you can have a sort of welcome function to provide feedback to the user. So every time it happens, rather than writing again, amen, 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 you just have value. But let's do something more interesting. So this allows us to introduce a little bit of maths. So what am I writing here? Well, actually, the point is that you can use SuperCollider to do your own computation, how much money you have spent. And 5 plus 6, of course, it's equals 11. So this may seem obvious, but it is not, for a couple of motives. The first one is that, yeah, this works, it returns 11, but what about our idea of object message? Can you spot the object? Can you spot the message or the dot? Is this something that, okay, it works in our normal everyday life, but shouldn't work in this formalized context? Isn't this a contradiction? Well, it is not, because again, the point is that this is the object to which we are sending a message. This is actually the message, and this is the argument of the message. The only point, we could expect something like this. This does not work, okay, but it's just like writing this. So why not use this, which is precisely what we are expecting, and later using this? Well, of course, because this is much shorter and we are so used to it that if suppose you want to implement some calculations, some mathematic black magic, if you have to use this kind of syntax, it will be really cumbersome and so terribly boring. So actually this works, but its real meaning, it's something like this. Please note that this is a pseudocode, so this does not work. But the point is that actually plus is a method for, in this case, integer numbers, and this is the argument we are passing. So if you read it in this way, it's just always the same. In fact, it may happen that you know that the asterisk representing computer programs the times operator, so 5 times 7 is 35, and this is 5 divided by 7, and of course this is minus, and you get negative numbers. But there are some operations that are interesting in terms of syntax, like this. This double asterisk, it's the square, so it's 25, and following the same kind of syntax. But in this case, we have also the possibility of writing something like this. Now, this makes sense for us, no? This is a sort of alternate way of writing the same thing. So 5, elevate yourself to the power of 2. Object message, that is receiver message, 25. And by the way, just to make things a little bit, I don't know if it's easier or more complicated, probably both in some sense, you can do this. 5 squared. You might also want to speculate that these are not the same. Well, you look at the screen and you see that they give you, let's clean it up. Let's see this, 25, and let's see this, 25. So it's the same. No, not exactly, because if you see you have 25.0, meaning that what is returned is a floating point number, while 25 without 0, this is an integer number. Typically, you won't care about this, but actually, as you can see, there are two different objects, and as usual, you can inspect them. You can inspect them. So, the point here was that here we have a sort of this is a working method that implements the kind of logic we were expecting from something like this. But the point is that this is just an abbreviation for this kind of, for a syntax like this. Okay, so let's do something like this. F, it's a function. It asks, it's simply what is performed in this program, embedded, encapsulated into the function, is elevating 5 to the power of 2. But it's not evaluated. It will be evaluated every time we call it. Fine. So you may ask yourself, okay, fine with this idea of function, but actually they are pretty useless, because, okay, I mean, 5 power of 2. Why should I embed this into a function? Well, in this case, maybe it's useless, but let's consider the point in programming is always generalization. So what happens if rather than having 5, we have a function that performs the multiplication of a general power of 2 of whatever number. So the point is that we would like to say f, please elevate to the power of 2 something that is provided to you. In fact, we can use argument in the function, and I'm using well, okay, so in this case what happens is that we have introduced a reserved word. You see that it takes a different color. It means that this is the argument of the function. We have encountered arguments. Arguments are passed to methods. In fact, what is a method? Well, at the end, an object can be thought as a sort of collection of specific functions. So every time you send a message to an object, it's just like that you're asking this object to perform the content of certain embedded function it has. It's methods. So, like we have arguments in the method, we can have argument in function. In this case, x is what we pass to the function f. So, actually, now here we get a mistake, we get an error, because now x is not specified anywhere, and if this is nil, if x is nil, then x power 2, it cannot be performed. So now what happened here is that we are passing a value for the argument x, and now this works. So actually we have generalized the function, and now our function is makes the power of 2. Of course, you might ask yourself, yeah, but wasn't this easier to do by simply multiplying a certain value, elevating to the power of 2? Of course, but you can generalize it more. And well, let's call it exp. Now we have 2 arguments, like 5 and 2, and we have 25, but we can have 3 here to the power of 4, and we have 81. So this is more general. But let's consider something that is a little bit more complicated, because actually, as you can see here, our function includes a declaration of arguments, first expression, second expression that has to be performed. Can we do something a little bit more complicated? Well, sure. We can think about Pythagoras, and we can have a function f making a Pythagoras, calculating the I'm not so sure about the English terms, the hypotenuse starting from we call it cateto. I don't know if it's catet, I'm not sure about this. The value of the 2 sides of the rectangle, of the triangle with the 90-degree rectangle. Okay, so here what we want to do is to pass the I'm calling this cateto, I'm sorry, cat1 and cat2. This will be our arguments, because our idea will be to calculate the hypotenuse. And what we want to have down here, what we want to have it spit out is the hypotenuse. So this is getting a little bit more interesting, because here we will have to take let's write it in a sort of pseudocode, cat1 squared. Then we know that in Pythagoras we need cat2 squared. That's not enough. We have to sum these. And what have we to do here? Well, actually, what happened here is that we need to have them squared. So we can have something like square sum. We call it square sum. And then we might say that hypo is square sum. We need the square root in this case. How do we make a square root? Well, it's another mathematical operator. You might find all the mathematical operator under simple number, this simple number, or under integer. or under float, or under probably something like magnitude. Okay, so the message sqrt, the message square root, send to a number, ask the number, the object number, to return the square root. So this is easy because we can do something like this. So what happened here is that the idea in our function is that we have two arguments, because we want to provide, to feed the function with the variable numbers of our of the two sides of our triangle. And I can try to do this in a sort of orthogonal way. Then we are saying that we have a certain variable that will contain the sum of our squared arguments. Then we say that our hypotenuse should be the square root of the sum of the squared sides, and then we want to return the hypotenuse. Now there is something that should not work for you here, is that we have introduced sq sum, square sum, and hypo, but we say that we can only use single letters. This is still true, and if we want to use variable names, more complex and more meaningful, we can, of course. We have to declare them, and we declaring a variable means that we are declaring to the interpreter that we use some labels as names. So first we declare the existence of these labels to be used. We do not have to do more complicated things like saying the kind of object that we want to introduce into our variables. So we do not declare the type from a technical point of view. But what happens is that we declare the use, and this declaration must be on top of your program. So here we declare two variables. Then we can use them like this. We could write the, well, let's try and see if this works. No, there's a mistake. Where is this mistake? It is here, because we forgot to add a semicolon. Now, by forgetting this, what happened is that the interpreter is collecting characters, going here, and now this expression, as you may understand, doesn't make sense. Of course, I have forgot this because this was on a next line, but the interpreter does not take into account the idea of next line. It's not meaningful. So here I'm saying that I'm separating the expression. How many expression? Declaration of arguments, declaration of variable, this expression, this expression, this expression. You might ask yourself, why aren't you adding here a semicolon? I can, if I want. Maybe it is a good practice, but the last expression, in the last expression, you can omit the semicolon. If you want to add it, fine, better practice, so you are yourself into this idea of adding semicolons. Let's see, fine. So now we will perform a computation of a homage to Pythagoras with two classic values, and we know that the result must be 5. So if it is 5, it works. It's not, so there's a mistake. Yes, there's a mistake, and probably you saw it, but actually, as I told you, debugging is important. That should be 2. I was adding the squared the square of the same cathete. Now the point is that we need to use 2 cathetes, and it's 5, so this works. So can we add something more? Yes, we can provide default values if you want, like in methods. You see, that's the same logic. So in this case, what happened is that if we do something like this, well, this does not make much sense for Pythagoras theorem, but actually it still works. If we use this, if we evaluate this, we get 5, because by not providing cut 1 and cut 2, they will get the default values. Of course, for Pythagoras this is not so much meaningful, but can be interesting in other situation. So a lot of things going on here, actually, because we have a complex program here. Well, you might say not very complex, but not bad, because we have a typical construction function, which is arguments, but all this is a program that we can run by itself, maybe in this way. Now let's suppose that this becomes as imperative style program. So we need to cut one. Well, you can see that I can declare in different expression the variables. Point is that variables must stay in the top block, and cut 2 equals 4. So these will not be legal. They must stay here on top. Now this is a classic imperative style program, because we're trying to calculate the hypotenuse from 3 and 4. And by the way, well, yeah, we can do something like this. So this small program, let's add some feature. Okay, so this is a small program doing the same things that we have done before in a more structured way. So suppose you can forget everything before and you create a small program to calculate the hypotenuse. How to create this? Well, you might ask yourself, what is this? Why this parenthesis? The point is that the parentheses, they have no syntactic value, but they are just used as typographic means, because if you double click here, you select everything inside the block. And as we saw, the point is that when we want to run something, we have to select the expression we're interested into. So this could be boring, but if you double click, it means that they will be selected together. So it becomes also a mark to say that that block must be evaluated together. You place this block between parentheses. So now this is our small program, and it has interesting features. So top block, declaration of local variables, then some computation, and finally it posts the hypotenuse. It works. Well, we could make something like this. The hypo is, and in this case we do post. So we see also what happens with post. So you see calculation happening, then a string is printed on the screen. It's post and not post line, so it does not go to the next line. In fact, we have hypo post line. Hypo is posted here, it's 5, and then next line. So what is the difference between these and these? Well, apart from some cosmetic aspect like this, the point is that suppose you want to calculate many times the hypotenuse, and sometimes maybe you do not know where to calculate the hypotenuse, sorry. We have just taken a program like this and we have encapsulated inside the function so that we can use this every time we are in need of. So interesting things, two interesting things. The first one is the notion of function as a way to encapsulate a program, and secondly, as a curious side effect, a small working program. This is a way you can create a program. Now you may ask yourself, why declaring variables when you can use single letters? Well, the point is that these variables are different from these variables. These are local variables. They are only available inside the block which is evaluated. So I'm cleaning the post window and re-evaluating. Now you ask yourself, SQSum, what is its value? And you get an error. And the error says, variable SQSum not defined. How? We have defined it. Well, we have defined it. We have said that we want to use this variable, but it is local to the computation. So once we have made the computation, so once the program has run, SQSum doesn't mean anything anymore. Is no more available. And yeah, but what happens with let's say with f? F it's a function, but we have defined it before. So what's the difference? The difference is that when you use var, you define local variables. They are local to your computation, to that block. When you use single letters like this, you are using environment variables, meaning that they are available for all your working session with the active interpreter. And by the way, you are not forced to use single letter in order to have this environment variable. You can also use standard name like this, that can be of course more meaningful, but they have to be, no, I want to do something different, SQSum. They have to be prepended by this tilde sign. So if you are not finding your tilde in the keyboards, you need to find the shortcut. So it is surely available. Where the key is placed is up to you to determine. So these are environment variable. These are local variables. Where to use local, where to use environment? You use local when you have a block to be evaluated and you don't want any kind of interference from outside. So you can use whatever you want. You're not forced to take into account other variable name. You just can use those names and they will be lost outside that block. This will be a sort of well-organized, structured block of code. But sometimes it's useless to have things keeping on working while you're programming, because we are doing interactive programming. In that case, you use environment variables. Typical question, why should I not always use environment variable? Well, the point is that you can make big mistakes. You can mess up a lot of things with the environment variables because they keep living and they keep having value, and maybe when you are interacting with your computer, you're forgetting about those variables, in particular if you're using single letters, but then they keep on having a certain value and everything can be messed up by this kind of permanence. So to sum up, when you have a structured block of code to be executed, you use local variables. When you are using variables in order to interact with with your program, with SuperCollider, you use environment variables. So if we look back here, we see that this function, a function, can be thought as a container for a program. And in that case, of course, we use local variables because we want to execute that block without any interference from outside. The function is just like a block, a sort of black block and a black box, and the only inputs that we want from outside should come from here, that is from the list of these arguments, and the only way to communicate for our function should be, in a well-designed program, what is returned by the function, that is, the value of the last expression. In this case, we are ensuring that the function works really as a black box, and we are absolutely sure that no strange things can happen by calling the function. We provide values, it gives you back a certain value, and that's all. So, along the tour, in order to create a function, but we have learned something. We have learned something, and now we can make function. And let's go back. We call them nodes. Let's go back here. Now, we still having our knob, those big knob placed on a purple violet background, and we want to make it work. And in order to make it work, we must set its action method, and its action method, the action method, takes as a value a function. Why? Well, we say that a function is a sort of block, a program that can be evaluated on demand. So it's exactly what we are expecting for a knob. Every time there's a change in the status of the knob, something must happen. That is, we can say a function must be evaluated. So let's try to do something simple. We like this Diode Lebowski style writing. We can put it on a single line if we want. So what happened here is that we say K, set up your action with this function. This would mean that every time we move the knob, the function will be evaluated. Now our function here just prints on the screen, hey man. So let's see what happens with the knob. Hey man. So of course it is working. Not very interesting, but it demonstrates that the whole thing, the whole architecture is working. This is also interesting when you program. First, make things work, then do the things in exactly the specific way. So the point is that, okay, the so-called binding between the graphical object and the action is working, and now we do something more clever than this. So, point is that we want to change the background of our window. So the point is that we want to have a new color here, like this. So every time the knob is turning, the background color of the window is set up. Now, an interesting construction for color is rand. Rand is a constructor in the sense that it returns a new color, but with random values. Well, by the way, you can also change some parameter of this randomness. But if you evaluate many times this expression, you will see that a new color is posted on the window with different values, because it's random. Now, this is interesting for us because, again, it is a way to understand what's going on. So now we are expecting to have a sort of behavior more similar to what our target in some sense. So let's move this, and you see that every time we move, random color. Well, this is interesting. Can we do something better? Well, yes, because the point is that now something is happening, but when you have a knob, the point is that typically you don't, the typical intended action is not to have random behaviors. Otherwise, you do not need a knob at all. You just can press a button maybe. So the point is that you have a scale, a range, and that scale is useful from minimum to maximum volume, as an example. from minimum frequency to maximum frequency. It's an oscillator maybe. Right, so the point is that we need to access the value of the knob, because the action should depend on the value of the knob. How can we access to the value of the knob? Well, we can declare a variable like VL and say that K value. So what we are doing here is that the variable VL will take the value of the knob. Now note that this is a function, so this variable is related here. And what can we do? Well, we are lucky that the value, well, we can do with maybe RGB. Well, typically what happens with RGB is that well, we can do the easy way from start. So let's say we have a fixed value of green and blue, or maybe we can have HSV, and we can control the saturation with hue in this way. So what's going on here is that we assign to VL the value of the knob. The value of the knob will go from 0 to 1. Then we say, hey, W, your background should be color depending on VL, which is used as the hue. So from red to red again, passing through all the colors, like the color wheel, with fixed 1 and 1 saturation and value. Now, as you can see, we're moving in a continuum, because we start here from 0, then we pass through the color wheel, green, cyan, blue, purple, and we reach red again. So we're using the value. Maybe for the bug we want to see something on the screen. Typically printing on the screen can be computationally intensive, and so it must be used only in the bug. But in the bug it can be interesting, because we see what's going on and we see the value of our knob. Right, this is cool. Well, of course, here we're using colors, but we can control everything in this way. There is only one point that still must be a couple of points. First of things here is that there's something wrong going on here. It becomes transparent and we cannot see the color anymore. Then we move it and it's fine. And here there's something wrong. So if we investigate color HSV, Control D over HSV, and we go to color, and here we are, you can see that in this line, you see that the arguments are hue. It's a float, fine, going from 0 to 0.9999, so not to 1. The point is that, so there's a limitation due to implementation. So when we reach 1, we are going over the maximum available value for hue. Hue must be specified between 0 and 0.999, not 1. So the point here is that we need to do something with this extreme condition. So there are various approaches to do this. One could be this one, VL. So we are reassigning VL, or maybe we can do something like this, clear. Var hue is VL, and we are mapping a domain to another domain. In this case, we start from 0 and 1, which is the domain of our knob, and the domain of values in which we have to map this knob range is not 0 and 1, but it's 0.999. So we are projecting linearly a domain into another domain. Well, in this case, it might be not so clear, but think about sound. Let's suppose you are controlling frequency. Now, 0 and 1 doesn't make any sense for audible frequency. What is the range of audible frequency? Well, it could be 20,000. So at this point, the idea is that we map the range of the knob 0 to 1 to a codomain 20 to 20,000. Suppose you are controlling an oscillator, creating a frequency. The idea is that the minimum is 20 and the maximum is 20,000. It's not fixed. We can decide these ranges. Maybe we want to start with 100 Hertz and going just up to 2000 Hertz. We do this, which is a linear interpolation algorithm. There are also other interpolation possibilities. Here we are using linear interpolation algorithm, which is a sort of projection of a domain into another numerical domain. In our case, we are using this to do something very simple, like, so it substantially is the same, but it's just a bit, well, it's a bit compressed in some sense. So let's see if this solves our issue. Yes, forgetting semicolon, a classic of mine. So let's see if now we were in a difficult situation, and now there's still something. Yes, the bug. Here we have calculated U, but here we have still with VL. Now that should work. Let's see. Fine. Now we are printing on the screen the value of VL, and correctly the value of the knob is 1. But what will be output by Hue, by this mapping algorithm, which is a message linear mapping to value, is 099. So as an example, we can also interpolate this here. You see, every time we move, it's not so clear, but every time we move, we are posting two values. And here, as you can see in the extreme condition, 1 becomes 0999. And if you are here, you'll just look at the last two. They are almost the same because the two ranges are very similar, but they are not the same. This is a possibility. The other possibility will be to use some other numerical value like this. So we comment this, and we do something like this. Rather than mapping, we can do something like this. 6. No. Clip 2 maybe. Yes. So 6, clip yourself. The method is clip 2 in this case. 7. No, that's not what I want to do. No. Okay, so let's do this. Let's do this in this way, maybe. Let's investigate various possibilities. What happens here? Should be no. I can use this probably. The easy way is this one. So here we are asking to reply with the minimum between itself and the number we're passing. As we're passing 5, the minimum between 4 and 5 is 4. So, of course, if we increase this number, it will be always 4. The minimum between 4 and 8. But let's suppose we do 9. The minimum between 9 and 8 is 8. So this actually works as a single sort of threshold. We can do this in various ways. I was trying to find of course there is also max if you want. So let's suppose we have this is our threshold, and we want to have the minimum between these. So here we have 0, but suppose we turn the knob. This is the value of the knob. Let's suppose we reach 0.9. The minimum is 0.9. But what happens if we have 1? The minimum is now this one. So actually a possibility will be simply to use a minimum between the value and this. Let's see what happened in this case. And it's still working. Here, as you can see, the last two values, because we're still plotting two values, are the same value. So the point is that it can go up to 0.999, and then all the values above 0.999 will be clipped to 0.999. Okay, so this is there is still one thing that we have to do, which is important, and the thing is the following. Here we are inside the knob action. We are accessing the action of key in this way. Now, where is the defined key? Externally. It's not the point that it is an environment variable, maybe also, but the point is that key is something outside the function. This is not very good, and there is not a notion of self. So the point is that when we define the action of a knob, we'd like to have a way to specify that the action must access the knob itself, not a knob defined externally, like in this case. So what happened here is that when you move the knob, every time the status is updated, then the function is evaluated. The evaluation of the function, so it's just like sending to the function we're defining, this one, a value message. The point is that we are passing, or better, the interpreter is automatically passing to the function the object knob. And then you can decide if you want to use this or not. This is quite abstract, but we can provide an example. Let's consider this function here. It has no arguments, right? So, can you do something like this? Yes. You are passing an argument. The argument is not declared at all. It is not used at all. Still, you can pass this. But you can also do this. Now let's consider this function, f, where it includes an argument, and then it performs an operation without taking into account the argument. So, an argument can be passed, but it is not used. It still works. So, the point is that, in our case, what happens is that we are in a situation in which every time the knob is moved, something like this happens. So the function is passed, the knob, the single object k, let's call it key, the single object is passed to the function. Now, to use this object or not, it depends on the way in which the function is defined. So here we have arg what? Well, arg knob if you want, but as the action is related to the knob itself, sometimes I call it me. And this is a way in which we can access the object itself internally. If we don't want to use this argument, we can avoid to declare it or declare it and not use it. This is up to us as a coder, but for sake of I don't know, for our happiness, the interpreter is still passing the object to the function. If you want to use it, you can use it. So now the point is that we can define this action. It works exactly like before, but the point is that we are saying something like the value is the value of the knob itself. It's just like having a sort of self-definition. So action, take the object or the value of action of the knob. Take the object, the value of your value knob and do something with that value. To sum up, this idea here is that the interpreter is passing the object knob so that we can internally access this value. We could also destroy the object itself internally by turning a knob or pressing a button. So this is better written. It works exactly like before. And now we have a program. Let's destroy this. Now suppose you are happy with your program. Can we do this better? Yes, we can do this better because we want to have a sort of, let's call it, standalone program. So we want to avoid environment program, and by this is legal because we're declaring W not as an environment variable but as a local variable. But we can, if we want, we can avoid any fuzz like this. We declare a window and a knob. We are doing some cleanup. We call this knob. We call this window. We say that knob. You see that in this case we are not changing this because it's always the reference to the knob. We avoid posting values because it's computationally more intensive and now uses because everything works. We call this background changer. And it seems that we have a nice piece of code. We test again to see if in our cleanup we are not missing something. It seems that this works and we have a program. That doesn't work. It doesn't work because this should be... Now, this is interesting. There are no mistakes, but it doesn't work. Why? Because W, it's an environment variable and still exists. So we're asking to change the value of W. That's the point of using environment variable, can be dangerous. It wasn't a mistake in the sense that this does not make any kind of mistake, but it's changing the value of the other window. This one, check this. Hoopla. So that's why it can be dangerous to use environment variable. So let's close this. Let's close again this. Our point was this one. This should work. Let's see. We have used the parentheses to group the block of code. Let's see this time if it works as expected. Fine, we have a program. The background changer, small graphical program written in SuperCollider. Next step, to save it. And we call this background changer. You see that in SuperCollider typically we use camel case. It's just a convention, but it's used by most of the programmer. And I will place it in my desktop. Save. Now we have background changer SCD. So we see many things related to not only GUI programming, which is interesting, but related to interaction between objects, some numerical methods, the idea of function, which is very important. Maybe we can proceed by introducing in a short video, but I'm closing this one, iteration and conditionals, which are the point of control structures, are very important in programming. So that's fine for us. Try to do this. Please do not try to do this at home. That's the contrary. Try to do this at home.